Hello everyone, welcome to MISIANI'S online mathematics, and today we are going to solve a question from vectors. And the question here on the whiteboard, the question says in the figure below, point OA or line OA is represented by vector A. OB is represented by vector B, as shown, and BX meets OY at point C. So we are also given that OX to OA is in the ratio of 1 to 2. OX, OA. So from O to A is 2, but from O to X is 1. So meaning X is the midpoint of OA. So we can say that this is 1 and this is 1. So when you add 1 plus 1 gives you OA, which is 2. So we go on. BY is in the ratio of 1 to 3 of YA. So from B to A is the total of 3 plus 1, but we know BY is 1 over the total now, which will be 1/4, and the remaining will be 3/4. That point. So the question here, part A, is asking us, express in terms of vector A and B, Roman 1, B over BA. Vector BA, which is BA right here. Let's see what we can get here. Roman 1, if we have BA is the same as, we can go BO plus OA, or we can go BX plus XA. But since we don't have BX for now, we can use BO plus OA. So this is the same as BO plus OA. Excuse me. Which is equals to BO is minus vector B, OA is plus vector A. We can rearrange this to be vector A plus minus, or here minus vector B. This is for Roman 1. We do the second part, OY. Let's see, what's OY? OY is given by OY, we can go to OB plus BY, or OA plus AY. Let's try use OB plus BY. OB plus BY, which is the same as OB is vector B plus BY is 1/4 of BA. But we know BA, we already found BA here. So this can be written as B vector B minus a quarter vector B plus a quarter vector A, which is equals to 1 minus a quarter. You will get 3/4 of vector B plus a quarter vector A. So this is the expression for Roman 2. The next one is Roman 3. Here we got is By, which is given by, let's see, By is 1/4 BA, 1/4 vector BA, which is the same as, we got BA already is here. So this is the same as BA times vector A minus vector B, which will give us a quarter vector A minus a quarter vector B. This is actually the result for part A, and allow me to transfer this up here to create more space for part P. Let me take this up here. BA, we found this A minus B. OY is a quarter A plus 3/4 of B, and lastly BY equals to a quarter vector A minus a quarter B. So I can erase this to create room for part P now. Okay, let's see what part C is saying here. Part B says, given that OC is HOY, OC is H times OY. So OY is 1 unit actually. So if we say OC is H, the remaining will be 1 minus H. And BC is K BX. So here will be K, and then here will be 1 minus K. So this is where the question is a little bit tricky, and you must be able to see how to solve this question by just finding a way of writing either OC or BC in two ways, so that you can form two equations to be able to solve the question. So for instance, we can write OC in two ways, since we are given already one way here for OC. Let's see what we can get. Let's say OC, the first one will be H or Y. But we know OY is right here. We found that from part 1 already. So OY, we will multiply that by H, which is 1/4 vector A plus quarters of vector B. The next part is also to write the same OC in the second way, which will say, let's say OC. We can also go OC, we can also go to OB plus PC, or OX plus XC. If we follow OB plus PC, we get OB plus BC, which will be the same as OB is vector B plus, what's PC? PC is K times vector BX. K BX. But we don't know BX. We can find BX. BX is the same as BX. We can go BA plus B plus AX, or BO plus OX. Let's go BO plus OX, which is BO plus OX, which is the same as BO is minus B plus, this is half, is the midpoint, so it's 1/2 vector OA, which is A. So if we substitute this right here, we will get that OC is equals to vector B minus, now K times this will give us K vector B plus K, this is the half here, half K vector A. So if we factor out, this will be vector B into 1 minus K plus half K vector A. This is the second expression for OC. Next, now, since OC, we have expressed OC in two ways, we can equate this expression to the first expression so that we can compare the coefficients of B and A, so that we can form two equations and solve for K and H. So let's take this equal to this one. So H into 1/4 vector A plus 3/4 vector B. This will give you, or will be equal to vector B into 1 minus K plus half KA. So since we can compare based on the vector B to vector B and A to A, so let's equate 1/4 H vector A to half K vector A. This term here and this term here, by opening the bracket with H. So the S will cancel out there, and if we multiply by 4 both sides, this will give us something like K h is equals to 2k. This is our first equation. The second equation, we equate vector b to b, so we will have 3/4 h vector b equals to b vector b into 1 minus k. So the b's will the vector b will cancel out, will remain with the 3/4 h equals to 1 minus k. If we multiply both sides by 4, we'll have something like this: 3h equals to 4 minus 4k. Since we know the value of h from our first equation, we can substitute this to our second equation here. The value of h is equals to k. So if we put this value of h here, we'll have 3 times 2k equals to 4 minus 4k. So this is the same as this is 6k. If you take this to the other side, it will be 10k equals 4. 10k equals 4. This implies or means that our k equals to, divide both sides by 10 will give us 4/10, or if you try to reduce this fraction, k will be equal to 2/5. This is the one value of k. The last one, we take this value here, we substitute for equation 1 here, we get h. Our h equals to 2 times 2/5, which will give us 4/5. So based on part B, these are the values of k and h. Even though it looks a complicated question, it is easy so long as you know how to arrange and write the question, forming the two equations, you will be able to get the answer correctly. Thank you for watching, and may you share this video, give it a thumbs up and subscribe.